Biomechanics in sports and exercise science. Investigate linear motion in S and ES activities. Task 2. Linear motion investigation. A1. Linear motion. Linear motion is a person moving in a straight line, rectilinear and curvilinear. Vector quantities are described as size and direction. Scalar quantities are described as only size. A2. Speed and velocity. Distance is how far something has moved. Displacement is how far something has moved from its original starting position. Speed is a scalar quantity measured in meters per second. To calculate speed, it's distance covered divided by time taken. Velocity is a vector quantity measured in meters per second. To calculate velocity, it's displacement divided by time taken. A3. Acceleration and deceleration. A measure of how quickly the velocity changes of something over a set period of time. It is measured in meters per second. Acceleration is a positive figure, but deceleration is a negative figure. To calculate acceleration and deceleration, it's starting velocity minus finishing velocity divided by time taken. A4. Inertia and momentum. Inertia is the tendency for something to resist a change in its state of its motion. The bigger the mass, the higher the inertia. Momentum is the quantity of motion something has. During the 200-meter run, rectilinear motion took place at my thorax as it was moving in a straight line, all at the same speed. This would be the same for Usain Bolt and Amber when they were running at the straight part of the track. However, as they were running on a track, they would have used curvilinear motion as they are running around the bend of the track because they were running along a curved line. Also, at our limbs, angular motion was taking place, at our arms and legs moved back and forth as if they were rotating on an axis. This means that general motion took place, which is a combination of angular motion and linear motion. The speed and velocity of Usain Bolt. Usain Bolt's velocity starts at 0 meters per second and increases to 8.93 meters per second in the first 50-meter split of the 200 meters. In his second 50-meter split, his velocity increased by 2.65 meters per second, getting him to a velocity of 11.57 meters per second. In the first 100 meters is when his velocity is increasing and reaches the max as he is putting as much effort in as possible to sprint as fast as he can. On his third 50-meter split, his velocity slowly starts to decrease and decrease by 0.51 meters per second. On his last 50-meter split, his velocity decreases down to 10.53 meters per second. This shows that after the first 100 meters, he started to fatigue, meaning he couldn't run as fast, which is why his velocity slowly decreased in the last 100 meters. Speed and velocity of Amber Anning. Amber's velocity starts at 0 meters per second and increases to 6.83 meters per second in the first 50-meter split. In her second 50-meter split, her velocity increases by 3.35 meters per second, making it to 10.18 meters per second. This is her max velocity over the 200 meters. Just like Usain Bolt, she is running as fast as she can and putting in loads of effort. In her third 50-meter split, her velocity decreases to 7.66 meters per second. This shows she has fatigued a lot and might not be trying as hard anymore because of it. And for her last 50-meter split, her velocity then increases again to 9.19 meters per second. This shows that she must have sped up because she realized it was the last 50 meters and wanted to get as fast as time as possible. So she put as much effort as she could in as possible for the last bit. Compared to Usain Bolt, it looks like Amber wasn't putting in all her effort throughout the whole of the run, as she slowed down and then regained energy to speed up towards the end. However, Usain Bolt's velocity time graph shows that he might have been putting all the effort in through the whole run, as he only slightly decreases because of fatigue. My speed and velocity. My velocity starts at 0 meters per second and increases to 6.96 meters per second in the first 50 meters. In my second 50-meter split, my velocity decreased to 6.93 meters per second. This shows that I may have been trying to maintain a steady speed to preserve my energy for the rest of the run. In my third split, my velocity gets to 8.9 meters per second. This is my max velocity over the 200 meters, where I realized I was halfway when I started to put in effort and go as fast as I could for the last 100 meters. My last 50-meter velocity decreased again to 5.5 meters per second, which was my lowest velocity over the 200 meters where I had fatigued. This data shows that Usain Bolt and Amber both had their velocity over the 200 meters fairly equal, with not much change as they tried not to slow down. However, my data shows that I tried to pace myself, and it clearly wasn't an effective way of doing this as I kept slowing down and speeding up, meaning I was never putting in maximum effort into the run. The acceleration and deceleration of Usain Bolt. Usain Bolt's acceleration in the first 50 meters is 1.59 meters per second. This is his max acceleration over the 200 meters, as it is when he starts from 0 meters per second and wants to accelerate quickly to get his speed up. His second 50-meter, his acceleration increases by 0.61 meters per second. This is because he has already accelerated a lot and is now slowly reaching his max velocity. In the third and fourth split, he starts to decelerate because his fatigue and his velocity is decreasing, meaning he is slowing down. Acceleration and deceleration of Amber Anning. In her first 50 meters, her acceleration started at 0 meters per second and increased to 0.93 meters per second. Like Usain Bolt, this is her most acceleration over the 200 meters, as she started at 0 meters per second, meaning she would accelerate a lot to get to reach max velocity as quickly as possible. In the second 50 meters, it increased by 0.27 meters per second. This is because she is slowly reaching her max velocity. In her third and fourth split, she started to decrease. Like Usain Bolt, as she is starting to get fatigue, her velocity decreases, meaning she starts to decelerate. My acceleration and deceleration. In my first 50-meter split, I accelerated at 0.97 meters per second. This is also my fastest acceleration during the 200 meters, for the same reason it is for Usain Bolt and Amber Annings, because I start from zero and try to speed up quickly to reach my max velocity. My second 50-meter, I didn't accelerate or decelerate at all. I stayed at a constant pace. My third 50 meters, I started to accelerate again. This is because I tried to speed up and put maximum effort into the last 100 meters. The last 50 meters, I started to decelerate because of fatigue. Overall, the results between all three athletes were fairly similar, as we all had our biggest acceleration at the start when we were trying to reach our max velocity. Inertia and momentum. Usain Bolt has a mass of 94 kg, Amber has a mass of 61 kg, and I have a mass of 67 kg. This means that because Usain Bolt has the highest mass, he will have the highest inertia, meaning he needs to apply more force to overcome that inertia. It also means that because Amber has the lowest mass, she will have the least inertia, meaning she will have to apply less force to overcome her inertia. Inertia and momentum of Usain Bolt. Usain Bolt's momentum in the first split is 839.29 kg/ms-1. This is his lowest amount of momentum over the 200 meters, as it is his first 50 meters where he has had to overcome his inertia and start moving, which is why this is the lowest point of momentum. His second split, his momentum is 1087.96 kg/ms-1. This is his max momentum as he has also reached his max velocity, so he is moving quickly and has loads of momentum. His third and fourth 50 meters, his momentum starts to decrease. This is because he starts to fatigue and his velocity starts to decrease, meaning his momentum decreases as he can't keep his momentum up. Inertia and momentum of Amber Anning. Amber Anning's momentum in the first split is 416.67 kg/ms-1. This is also her lowest amount of momentum over the 200 meters, as it is her first 50 meters where she had to overcome her inertia to start moving, which is why it's her lowest point of momentum. In her second split, her momentum was 621.18 kg/ms-1. This was her highest point of momentum as she had reached her max velocity, so she is now moving quickly and has a lot of momentum. Her third split, her momentum is 467.08 kg/ms-1. It starts to decrease as she starts to fatigue and her velocity decreases. Her last split, her momentum increases. This is because her velocity starts to increase again as she puts in maximum effort into the last 50 meters. My inertia and momentum. My momentum in the first 50 meters is 466.57 kg/ms-1. For my second 50 meters, my momentum was 464.63 kg/ms-1. My third split, the momentum was 596.09 kg/ms-1. This was my highest point of momentum as I decided to sprint the last 100 meters and my velocity increased, meaning my momentum increased. The final 50 meters, my momentum was 368.54 kg/ms-1. This was my lowest point of momentum as I started to fatigue and slow down, and my velocity decreased. Overall, Usain Bolt and Amber Anning had a similar momentum results, as their highest momentum was in the second split when they reached their max velocity, and then it started to decrease as they fatigued.